So I've been trying to figure out. I just want to be able to figure out how to let Gemini play Super Smash Brothers, and I've been trying to do this for a while, and it turns out that it's not totally easy. Um, and just out of curiosity, and I'm just taking a look at the chat. If you wanted to have Gemini play Super Smash Bros, how would you actually do it? Any ideas? Well, anyway, so it turns out that there's a couple things that you need. And so just to give you an idea, so I had kind of a naive implementation. And if you do sort of naive, if you have an LLM naively playing Super Smash Bros., this is what it looks like. So Gemini is always Donkey Kong, I'm Mario. And in this case, I'm just sort of chilling out. And anyway, Donkey Kong is doing all this random stuff and eventually falling off the screen. And so the question is, how do we get the LLM not just to play Super Smash Bros, but to play Super Smash Bros intentionally? That is it possible to use essentially the multimodal model to have something like a reasoning loop where it's taking a look at the game, sort of figuring out the state of the game, and then also planning, let's say, a series of actions to defeat Mario? Is something like that even possible with an LLM, and how can we pull it off? So David says, teach it how to win. That's true. That's true, and in some sense, that's the trick. Bob says, need to understand the context and the state. Yeah, that's good. That's exactly right. And so I guess the question is, if you're using something like a multimodal model and the model can see the game, the question is, does it have enough state? Does it have enough context to understand the game? And I guess that's something hopefully we'll figure out in the course of the talk. And Bob says that memory is needed. You know what? That may be true, actually. Especially if the LLM strategy evolves over time. I mean, if there's a set of heuristics that generally sort of win Super Smash Bros, maybe not. But let's see. So at the bare minimum, does anybody have an idea what you need to actually play video games with an LLM? So it turns out at a bare minimum, APIs, yeah, that's good. At a bare minimum, you need something like a virtual controller. So essentially, you need a way for the LLM to be able to, let's say, actuate the game. When you're holding a controller and you have A, B, X, Y, and directional, like essentially the LLM needs some analog to the sort of real-world controller. Okay, Yushin said real-time inputs and outputs, that's right. Nick said start with a LLM, a vision model. That's great. William said MCP. All these are fantastic. Virtual controller, I feel like, is kind of that's the sort of bare minimum. That's the sine qua non. And then let's say if we're going to do this multimodally, we have to have the multimodal LLM, and that is we have to have something that's capable of. Let's say if we don't have a vision model, maybe literally just taking a look at a screen and ascertaining the state of the game. And then also, and this maybe this is theoretically optional, but the way I wanted to structure this is I wanted the LLM to take a look at the game state and then essentially have a list of tools available to it. And I wanted a multimodal reasoning loop with tool use. And what that means is, like, let's say the LLM has a bunch of relatively high-level actions available to it, maybe sort of smash attack, high attack, low attack. It would be nice if the LLM was smart enough to sort of chain those into a series of combos to, let's say, beat Mario. Here's the sad thing, though, and this is I think this is something that probably belongs under future work. By the time you chain this all together, and we'll see what happens, by the time you have sort of a vision model, by the time you have this LLM reasoning loop and all this stuff, honestly, it takes about a second or two. And which means that with the LLM, you have to plan about a second or two into the future. And with Super Smash Bros., I don't want to say that's nearly impossible, but it's difficult because the state of the game changes. And author, I've mentioned state space rather than visual input. Yeah, that's good. That's good. And so basically, like, just at a sort of high level, this is kind of what I want the architecture to look like. So we just have this reasoning loop, the virtual controller. Basically, the game feeds into the multimodal LLM, calls tools, actuates a virtual controller, and then in this kind of virtuous loop. And so how do we actually do this? And so the way I wanted to do this is it turns out that if you ask the LLM to actuate something like frame perfect actions, it's too overwhelming. And so what you need really is you need a high level vocabulary. So you want to be able to define something like high attack, which consists of a series of, let's say, frame perfect actions. You push up, you push A, you release A at frame 8, maybe you go back to center at frame 12. And basically you want to be able to feed these to the LLM as a series of high-level tools. And so the nice thing here is that if the LLM decides to do, let's say, a high attack, it doesn't really have to think about sort of frames 0, 4, 8, 12. Like, let's say this low-level sort of actuator handles this sort of thing. So anyway, so that's sort of the first step. And then, you know what, just to see what this looks like, I just wanted to see what happens if we, just to make sure everything works, let's say we have this library of moves, and what happens if we just do some kind of random actuation. And I hate to say, I actually lost to the random generator, which is a little bit sad. But in any case, so this is Donkey Kong literally just randomly going through these moves. And in some sense, this is just a sanity check to see whether this high-level sort of mapping of moves to sort of frame-perfect actions works. And it turns out, anyway, it works reasonably well. William, let's see. How do you handle LLM agency, just a virtual controller, JSON event? Yeah, so essentially, the way I handle the agency is just through essentially this reasoning loop with the LLM reasons about, let's say, the visual state of the game plus some side input, and then calls a series of tools. And in some sense, I'm calling this roughly an agent. But let's sort of see what it looks like. Okay, now that we have this library of high-level actions, how do we actually hook it up to Gemini? And so let's say we have this LLM planner, and I'm really just going to create something like a consumer-producer queue. Essentially what happens is Gemini is going to push these moves onto a queue, and then there's going to be some thread running which just sort of consumes these moves off the queue and actuates them. And this is just this is kind of a high-level abstraction of what the code looks like. But let's say we instantiate the model, we bind this library of tools, and essentially what it looks like is we're just going to capture a screenshot. We're going to invoke the LLM with a screenshot, and then whatever moves the LLM comes up with, we're just going to push them onto this queue. And what it ends up looking like is something like this. And what's interesting about this, so this is just the LLM operating multimodally. And so what's interesting is the LLM is able to chain certain moves. Like you can basically see that it's kind of actuating Donkey Kong with a bunch of these, I guess in this case it's doing a series of smash attacks. But what's interesting, and I don't know if you can notice this, it lacks spatial awareness. So it turns out it doesn't really know whether Mario is to the left or the right. It randomly decides in the middle of this clip for some reason to start going right, but who knows why. And then you can see it just sort of goes off the edge of the screen. And so this is why, unfortunately, I think if you're working with the multimodal model, and I've seen this in things like even just web browsing, it turns out that the spatial awareness of the multimodal model isn't great. And so like, let's say you're trying to do other things, like let's say you want the model to browse the web. And in particular, let's say you have a bunch of elements and you wanted to figure out like how to go to Google search or whatever. It turns out it has a vague awareness of the sort of the XY of like the Google search bar, but you really have to feed in a bunch of side data to tell it, okay, listen, there's this actionable element from like, 100, 100 to 500, 500. If you click on that, you'll get some sort of Google search. And Bob asks, how detailed did you have to define the game and the rules for it in the system prompt? So the system prompt was actually, I played with it. So I had a really complicated system prompt where, I was saying, listen, bro, like you are Donkey Kong, I need you to beat Mario. And in particular, like choose the best strategy, don't do this, don't do this, don't do that. And I had this really long list of heuristics, and I realized the model wasn't performing very well. And so what I did is I really went back to the basics, and I just said, listen, you're Donkey Kong, your objective is to beat Mario. Here's the state of the game, and plan about a second or two into the future. Namely, let's say try to generate about 6 to 8 moves. And I noticed that the model seemed to perform a lot better. So how are we going to give the model spatial awareness? And it turns out this is where the vision model comes in. And you know what? I don't know if you've ever used this thing called RoboFlow. It's kind of beautiful. Basically, what I can do is I can essentially, I can feed it in like, I don't know, maybe 20 or 30 examples like this where I've annotated Mario and Donkey Kong. And you know what? In 15 minutes, I can train a model that's like, it's kind of like maybe 95% accurate. I mean, it's actually kind of a thing of beauty. And so really what happens is, so let's say we have this model that we've trained with RoboFlow, we have this vision model, and really the purpose of this model is just when it sees the state of the game, it identifies Mario, it identifies Donkey Kong, and basically draws bounding boxes. And the beautiful thing about these bounding boxes is then we can use these to establish something like a spatial relationship between Mario and Donkey Kong. And so let's say in particular, I get a couple of predictions off of the model. It sort of finds Mario, it finds Donkey Kong. And then literally what I'm just going to get is I'm going to get some XY coordinates. This is kind of a simplified thing. And I'm just going to pass them to the model. And I'm going to say, listen, Mario's at X and Mario's at X, Donkey Kong's at Y. And then in reality, I think I also have sort of Z in there for the actual prompt. And then I do some things like I tell it whether Mario's left or right. And I give it some hints. But basically, this side channel information, the spatial information is passed to the model alongside of the screenshot. And so essentially the model has both things at its disposal. And the fascinating thing is, it kind of works. So let's just see what it looks like. So here's our LLM planner. So basically, for this flow, we capture the screenshot. We call RoboFlow. We do the summary thing, and essentially we pass this summary to the model along with the prompt, and then we invoke it, and then we push these moves onto the queue. And here's what's interesting. So this is Donkey Kong with vision. And so you can see Mario's behind him. Oops, he's going to turn around. Like he sees that. Oops, he's going to turn around again. Like so, this is Donkey Kong apparently with some spatial awareness. I mean, things are still a little bit slow. That's just the LLM or whatever. However, you can see that Donkey Kong is actually reacting to the world in real time. This next clip was actually kind of cool. Oh wait. Let me see if I can, I guess it's not there. But anyway, so this is a step up from the previous example where Donkey Kong essentially had no awareness. And I thought I had a second clip in here, but I guess I don't. But anyway, I had a second clip where like somehow Donkey Kong was on the bottom, did this like sweet kind of flying attack. And anyway, so this is Vision plus LLM. And Syed says a reason it might be too slow to fight and actually win. So that's a great point. I think so. One of my favorite benchmarks, by the way, and I know there's LLM Arena, has all these kind of text benchmarks and image benchmarks. One of my favorite LLM benchmarks that's been around now, I think even for a couple of years, is like the Street Fighter benchmark. And so in some sense, I think if you have LLM versus LLM, and they both have the same constraints, that may be sort of an apples to apple comparison. I think it turns out if you want a competitive Smash Bros. Player that can compete against humans, I think you need two things. You need some low-level model that's doing like, I don't know, millisecond type of actuation, like let's say the tactical model, and then the LLM can step in as a strategic model to sort of like essentially work with maybe some RL model to do the actuation. And that sort of like dual model thing would be useful in a lot of ways. Like you could imagine, not only is it useful for video games, but things like, I don't know, stock trading or anything where you need a mixture of like tactical and strategic. But no, that's a great point. So that's about it. Let's see, I thought I had some slides in here. Let me just see 1 second. I had some slides in here about, give me 1 second here. I thought I had some slides about debugging with LangGraph. Give me 1 second. Yeah, the other questions for these sort of things is how do you? Oh, and by the way, this is just a clip here. This is just a clip here with Donkey Kong on the bottom. So Donkey Kong sees that basically he's negative on Z. He has this beautiful sort of aerial attack. Anyway, boom. So the question is, how do you debug these kind of things? And debugging in the console is actually it's actually relatively difficult. And so one of the things that I like to do is this thing called Langsmith, if you've ever used it. Anyway, it's kind of reasonably useful. And if you can see on the right, basically, given it just shows you given these inputs and what the output of the LLM is. And it just does this beautiful thing where, normally when I send the image to the model, I'm sending it as this like base64 encoded PNG, and then Langsmith will just translate that back into an image. And anyway, this is great for debugging, because you can see sort of what the reasoning of the model is, and some of the outputs it produced, the tools that it called. And this is a beautiful thing for just, I don't know, debugging some strangeness with Donkey Kong. And then I thought maybe, should I try to actually just do this real time real quick? Maybe I'll tempt maybe I will tempt the demo gods and actually try to play this real quick. Let me see if this works though. All right, 1 second. All right, so let's see if this actually works. All right, so DK is going in the wrong direction. Don't embarrass me, bro. Okay, let's just see here. All right, there we go. Okay, there we go. He's coming back. He's coming back. But as you can see, he's basically, it's just too, I think it's just, in its current state, it's just too slow. And in fact, maybe the reasoning loop is even done. Oh, there we go. Okay, he's coming back. He's doing a little something. And, but yeah, basically, I think to your point, it's essentially, it's okay. I think if I were doing this with LLM versus LLM, like it would be okay. But I think we really need to get some of these low-level models to do the actuation if we want to become competitive with humans. Anyway, thanks everybody. That's about all I had, and I don't have this up on the GitHub yet, but I'll have this up probably later today after I just clean up the code a little bit. And with that, I'd love to take some questions if you have any.
Let's give people maybe a couple more minutes to ask questions if they have any.
Oh, hey, what's up, Serge? It's good to see you, man. Trading applications. Yeah, I mean, that was a while ago when I was doing, I did this Gemini does day trading thing. And you know what? I ended up making a couple bucks. And I noticed that it was fantastic for unstructured data. So I could pass a bunch of 10Qs. I could even do some sentiment analysis on X or whatever. Like all that stuff was beautiful. Anything numerical, though, forget about it. And, and so typically, so my trading stack looked like just deterministic Python to like capture some of the metrics, and then essentially round it out with a little bit of LLM for some of the unstructured stuff. And, I could pass like, I don't know, years worth of 10Qs and just to get an idea of the trajectory of the company. And that ended up, I don't know, I didn't lose money. I guess I'll put it that way, which is kind of nice. How soon do you see LLMs being added to video games? You know what? Probably now, right? I mean, the thing is, it has to be a fantastic way to spin up a bunch of NPCs, right? I mean, that way you don't even really need to worry about dialogue anymore. You just tell the LLM, hey, bro, listen, you're this NPC. In fact, here's a screenshot of you. I don't know, you're a farmer, whatever you are. You're a fisherman or something. And here's how you fit into the overall narrative. Have fun, talk to the human players. I don't know. I could see something like that. I could even see something like we're doing some experimentation where LLMs generate some of these three-dimensional spaces. I could see something like that. Although again, the LLMs with like spatial reasoning, not totally great. And actually, I had this one. Let me just see if I have this real quick. Oh yeah, maybe I'll bring this up. So I don't know if you can see this, but this is this experiment that I did. Probably sometime last year, where I had Gemini just generate buildable, quote unquote, buildable Lego sets. And I think CMU came out and did something in the meantime. But this was this like self-portrait of Gemini. And I don't know if you can see it in the stream, but essentially it's sort of a buildable Lego set. But if you take a close look, like you have pieces kind of occluded in other pieces. And so like basically in order to build this Gemini self-portrait in Legos, you would basically have to whip out a saw and somehow, I don't know, cut Lego pieces like a puzzle, 3D puzzle. Anyway, a little bit, this would be a difficult set, but I thought this was a little bit funny because you can see what looks like a mouth. There's a couple eyes. I guess it has leaves for hair. Anyway, but this is what Gemini thinks it looks like, which is kind of funny. But yeah, its spatial awareness is like a little bit mid or whatever, let's say. Maybe if you made the bots fight, we could turn this into a sports betting app. Yeah, literally. And in fact, to a certain extent, that's done in the sense that, like, I think sort of like LM Arena has these leaderboards for, and I wonder, maybe I can actually find that real quick. Leaderboard Street Fighter. Let me just see if I can find this. Is this it? Let me just see here. Oh yeah, okay. So this is an article from a while ago, but yeah. So 3.5 back in the day was a champion of the Street Fighter. Oh yeah, LLM Coliseum. So like in some sense, that's sort of you can kind of see that thing happening, which is funny. What is your token budget for a game? Tokens per minute. Oh, that's a great question. I'll tell you the truth. So when I was debugging this thing yesterday, just between, what was it? Just between Langsmith, Gemini 2.5, doing a little bit of vibe coding, and then all the tokens for the game, I probably spent about maybe $100 yesterday. Just kind of like, anyway, like sometimes I'll go in X and somebody would be like, okay, bro, listen, if you're spending less than $3,000 a month on cloud code, like you're not doing it right. And so somehow it seems like people expect you to spend about a mortgage a month now on LLMs or whatever. But yeah, I dropped a few bucks yesterday. Okay, what's the benefit of LLM-based solution compared to detailed rule-based solution? Yeah, you already spent a lot on the system prompt. Yeah, no, you know what? So I purposefully kind of chose like the old school Smash Bros, like I think this might even be the 64 Smash Bros, because in some sense the game is much simpler, let's say, than recent incarnations. And in theory, yeah, I think you could probably get away with, not even a system prompt. You could probably just get away with a set of hard-coded heuristics and do pretty well. So yeah, in some sense, maybe the goal wasn't necessarily to like win Smash Bros, but was just to go through this exercise of getting an LLM to control a game. And I know recently, I think, what was it? I think famously, like Gemini, I think, sort of beat Pokemon. I think there are a series of games, probably turn-based games, where LLMs would do reasonably well, because there's no time constraints. So I think with these, like any racing game, any fighting game where the state of the world changes like sub-second, yeah, that's a little bit tough. But if you go into like RPG, maybe LLMs are sort of a natural fit. Is LangChain my favorite agentic framework for these kind of fun projects? You know what? It kind of is, and I don't know whether that's inertia. I mean, it's just the one that I picked a couple years ago. Typically, if I'm doing anything a little bit fancier, like I'm calling this an agent in a loose sense because it has kind of a reasoning loop and it has these tools and it has some actuation. But let's say I want something a little bit more quote unquote agentic. in the past, Crew AI has been kind of wonderful. And I know Google has its own agent framework we came out with recently, and then there's been some recent contenders I haven't played with. I think there's like Pydantic AI and there's some other stuff, and but anyway, these ones, at least these frameworks have been kind of nice. Data ingestion pipeline, and then use a prediction model in parallel to anticipate the moves, along with reacting to it in real time to increase reaction time. Yeah. I guess, I mean, in some sense, the data ingestion pipeline maybe is the reasoning loop, but you're saying maybe you can have a tighter loop, which let's say, yeah, that's absolutely right. Maybe even ingest real time video, or at least sampled at a greater frequency than like 1 to 2 seconds, and just the game state feeds that to the LLM. Actually, that's beautiful. Yeah, you could definitely do that in parallel, and maybe increase the performance of the LLM, and maybe that's something. No, that's interesting. I mean, clearly, in order to make something like this work, I think there has to be a tight loop, and where the LLM just gets to sit back, check in on the state of the game every second or two. It can kind of do its deep thinking, but like, let's say, okay, so this is kind of interesting. So let's say you do have some low-level model actually controlling the characters with like millisecond precision. And then maybe this pipeline that you're talking about sort of sits back, summarizes the state of the game over the past second or two, maybe talks about what the characters are doing, and maybe the LLM uses that information in addition to other game state to like feed something like strategy to the other players. Like maybe in this case with Mario and Donkey Kong, the LLM would tell Donkey Kong, who knows, Mario prefers aerial attacks, I don't know, try something else. So no, that's actually, I like that actually, that's great. How do you decide to apply LLM to Smash Bros versus others? You know what, my kids just happen to be playing Smash Bros. I think they were playing Zelda a while back, and I ended up doing something where, and I think Deepmind finally came out with this, but I created something like my kids are doing like a bunch of Zelda walkthroughs, and it was a little bit of a pain to sort of keep going back and forth between like YouTube and whatever. And so I created this kind of like this sort of LLM companion that would take a look at the state of the game and then try to tell you sort of what's next. Do you go to the fire temple? Do you do whatever? And anyway, that sort of thing is kind of interesting. But I wanted to basically do the experiment where we could see what happens, where we could literally play with the LLM. How do you connect the Agentic framework library to the video game I/O? Oh yeah, so that's so I'm just using this kind of low-level U input library, and just to give you an example, maybe of what that looks like. Just see here. Yeah, so essentially, I guess it doesn't really show it here. So, but the bottom line is that these sort of frame precise moves where you're moving up and you're pushing A. Essentially, I just feed these into this kind of U input device, and that ends up getting picked up. In this case, I'm just emulating over RetroArch. But so basically, RetroArch sees this U input thing as like a game controller, and then I just push these events, and like, I don't know, the magic of the kernel kind of takes care of the rest. And by the way, this was actually surprisingly tricky. Like imagine like Super Smash Bros has, I think it's like at least the old school one, it has like 16 to 20 kind of discrete moves, everything from these combo attacks to like taunt and throw and that sort of thing. And you have to define all these things with like frame level precision. I don't know, man. I mean, does A have to come 4 frames after up? Oof, like, I don't know. And a lot of these things I'm actually just kind of guessing. I suspect, however, that somebody knows exactly what these should look like. Yeah, that's great. So any other questions? So the other thing maybe I just thought I'd mention real quick is that if you happen to be in the Bay Area, give me 1 second. So if you happen to be in the Bay Area, we do this Gemini meetup every couple weeks, and so we host this at Google. And next one happens to be on July 11th. We're basically just bringing in sort of a bunch of interns to give some presentations. And if you want to join, it's just over at GeminiMeetup.ai, and maybe I'll just pop that in the chat real quick. Oh, let's see, can't use a manual, and then Bob says, can't use a manual sheet of the games and characters and let LLM come up with some strategies. Yeah, exactly. And in fact, Bob, so that's basically what I did. I think, somewhere on the web, there existed some like, what was it? It was like, I think it was just an exhaustive list of, let me see, let me share this. Sorry, 1 second. Let me also share this with you. Here we go. Yeah, so I'm also just sharing the survey real quick. But yeah, so Bob, that's exactly what I did. So like somewhere somebody compiled an exhaustive list of, let's say, like Smash Bros attacks, and I actually just fed it to the LLM, and I said, listen, can you take a best guess of I don't know, like, kind of frame perfect implementations of like a high attack or a smash attack. And you know what? It kind of did reasonably well. Some of them had to be tuned up a little bit. So I think the LLM in particular expected like really, really, really frame perfect actuation, in the sense that a lot of the actuation would be literally 1/60th of a second apart. And so you would be pushing up and then sort of a frame apart. But what I noticed, and I don't know if it was input lag or if it's RetroArch, so somewhere if you do these extremely precise controls, like they just get dropped. And so I noticed what I had to do is just loosen them up a little bit, and maybe instead of being frame perfect, maybe I need about a 2 to 4 frame buffer, just to make sure they don't get dropped by input. So yeah, so in some sense, I mean, it would be really nice if I didn't have to do any of that at all, and the LLM could just do this on the fly. And maybe it could. And by the way, in order to scale it, you probably have to figure out how to do that automatically. In some sense, the fact that I had to kind of program this library of high-level moves means that it's kind of not scalable. It means that if I want to do Mario Kart next, somehow like I have to do something similar, right? Which is a little bit of a pain. Oh, the QR link. Syed, the QR link for the survey or the GitHub? Okay, I thought I've got it. Nick says, your later action sounds like running book subception, inhibition, action, and intelligence. LLM is slow. Yeah, exactly. So LLM is a slow strategic cortex, and then really, it really needs to pass off these kind of lower level activation things to, I mean, it could be, I don't know, it could even be a set of heuristics, or it could just be a set of like, RL models, but something probably classical ML that's really quick. Oh, the GitHub. Yeah, let me just paste that real quick. And like I said, look for that to drop maybe later today. Maybe I'll just post it in chat real quick. 1 second. Yeah, so this is just the this is the GitHub link for that's just a lot of the code that we do for the Gemini meetup, and then what I'll do is I'll push the oh yeah, I'll push the code later on today when I get a chance. Limbic system, yeah, actually that's a great point. Something possibly that even like sort of sidesteps the spinal cord, maybe something almost like autonomial. And because I realize, I don't know if you have this experience, but I realize if I'm doing anything like playing sports, or I guess the same thing applies to video games or anything really, where you need these extremely quick reflexes, occasionally you have these things somehow, I don't know exactly how this works, somehow embedded in your peripheral neural pathways that, like, I don't know, it seems to bypass the brain almost, in order to have this just really, really quick reaction time. Yeah, that's great. These were really wonderful questions, by the way. And yeah, I had I don't know, I had a good time doing this. I guess there was a little bit more programming than I wanted. I kind of wanted to push a lot of the heavy lifting onto the model, and I realized that in some sense I had a little bit more. I have a little bit more Python than I'd like. I'll put it that way. Multiplayer role-based games, and other players can be LLMs. Risk games, yes, exactly. No, so I think the next thing is to, you're right, just make a kind of an MCP abstraction out of this. That's exactly right. And you know, I thought about that. What's funny, I mean, this was like really, really early on. I mean, we've been doing this Gemini meetup for like, what is it? I guess it's going on like 2 years or something. But one of the earliest things we did was just, somebody did a little Dungeons and Dragons thing. And it turns out that, like, at the time, I remember, this was a while ago, I don't know, just the context window of those early LLMs wasn't great. And so you had this experience where essentially you had like this dungeon master with amnesia. And so it would try to follow the train of the campaign or whatever. But I noticed sometimes it would go in these loops. It would hallucinate players and that sort of thing. But yeah, I think that's kind of a natural, I don't know, just throwing these agents into the mix would be kind of a natural thing.